What we're looking at here is the entire water system. And as you can see, it is mounted on plywood back, which is best if it's possible to do that, or to perhaps an adjacent wall or something close at hand to where the barrels of water are going to be kept. The system includes a solar panel system which connects to the two blue controllers that you see mounted just above the battery. Those controllers will control the amount of electrical energy coming from the panels into the recharge system of the battery, supplying the power which ignites the electrical unit, which I'll zoom in on here. As you can see, from the battery, it comes to this wire. This wire is through this orange cord. The orange cord plugs directly to the battery system from the controllers to the straightaway into this box. There is a fuse right below that if something shorts out the system, lightning strikes or whatever, this system will blow this fuse, and the replacement of that fuse will have to take place. You can see here the amperage. It's talking about how much electrical energy is actually going into the system, and as you can see right now it's 12 volt. Each one of these lights that you see here, when there is a problem, it should show up as a fault. When the pump comes on, as you can see here, it will show the ionizing going on. I'll see if I can ignite that for you so that you can actually see it working. The way in which I can do that is by fooling the system into saying that the float switch is now up in the air. So I'll just place it here to hold it. As you can see, it shuts off very quickly when the float is tipped down. The pump is now on, as you can see here, represented by the water coming out. The float switch that's in the right bucket, you can see that it is on its side. When that reaches, I can reach into the water. When this float goes into an upright position, as you can see on by my hand here, when it sticks in this position, it will also shut the pump off. So when one float, which is the first one I showed you, when that one is down facing, then the pump will shut off from the dirty water side, and when the one on the clean side faces up, as in my hand, then the water also will shut off there. The both have to be set to the size of the barrel which holds the water, both clean water and dirty water. The electrical wire that comes up, this is the one coming up from the pail on the clean side of the water. You'll see goes up here to the electrical panel. When this float turns here, this is the float as you can see in my hand. If you look here where my finger points, that light, that is to show the ionization is taking place. As I tip the float down, it shows that there's no water in the pail, and the pump comes on. Float up, shuts off. Here, electrodes, which are getting electrical energy at this time, because as the pump is passing water, it will shut off when this float goes into the pail and is hanging down. That shows that there actually is not enough water for the pump to run properly, so it will shut the system off. When both floats are in balance, That means that the one that is on the right-hand side is up. Then that shows that that container on the right is actually full of water. And when the one that is on the left, when that float is hanging down, then that shows that there's no water left inside the pail to transfer over to the right pail. And that shuts the system off, and you no longer will see this running. This light on, this amp meter showing, that means it's ready to go to work. So as soon as the floats, again, the barrels both have, they get the water in the empty one. That would be the one that is on the left. When that gets water, then that switch will come up. And as you can hear, the pump is trying to run. There is a safety in the pump itself, which means that when the pump is realizing that there's no water, it will try to run, and then it will shut down. But at the same time, you will see what happens. The light on the electrodes is actually showing that it's trying to put energy into these wires which come down, and it will send energy still to each one of these. And they should not have power in them because it will take the battery and take the energy from the battery, and it will also cause the electrodes to calcify. So the way that we stop this is by taking the float, and let's have it in the right position, which is down. And as you can see, no longer is the ionizer showing on, and you see that none of the electricity is able to go to any of the electrodes in the system. It shows you still the power is to the box. It shows you the voltage that you have coming from your battery, but it is not able to use the electrical energy because both the float switch on the right side is facing in its right position, and the float switch on the left with the dirty water showing it's in the right position, which is hanging down. And the wire that you see coiled up right now around where the battery is, that is coming from the float switch. There is approximately 20 feet of wire, both in the float switches, also on the unit from the battery to the electrical panel, approximately 20 feet of wire for that. And each one of the wires for the solar panel is approximately 20 feet of wire, and which is about 7 meters of wire. So there's so that the system can be put. This system here with the battery can be placed in a safe environment. Now, next on this would be stabilization of the pipes. As you can see on this view, if I can go back far enough here to get a shot at it, the pipes go into the pail. So if we're using 45-gallon drums, each one of the pipes that you see going down in should be stabilized. It can be stabilized by using a board or something, fastening it to the back wall. So you would go from the pipe to the back wall, and you would form a clamp around this to hold it in position. Also on the pipe that goes down for the filter, that could be stabilized from this pipe again to the back wall. You can just put a a support across for that. But these pipes, if children or anything come around the water supply and they start moving this is flexible and could break. So my suggestion, stabilize all of the pipes that are going in. Now the one that is on the right, which will go into the clean water, that is okay to allow the water just to drop into the pail, helps aerate the water. Also, you can hear the water so that you know that the pumps are on and that there is a water flow coming from this pipe. When that sound goes off, it's good. If there was an adult around that can come, just take a look at this box, make sure everything is running fine on it. As you can see, each wire is marked dirty water from float switch, clean water float switch, energy from battery. So everything is marked as it belongs. And when the system is not in use, it does not hurt it just to turn it off. When you turn it off, you'll notice the amp meter does not show any, and neither does the fuse. When you turn it on, amps go up, fuse lights up. Now this system is ready to actually operate. Any questions I should have, that we will also put this in on paper, and you will be able to go back and look it up for that. Remembering this wire is not to be hooked to anything. That is for future use. So I will tag it off and not have it serviceable. Okay.